Hi. My name is Victor. And since I started my PhD 2 years ago, there's been one very important question that makes me shiver. And it's why do we care? Why are we getting money for that? And so, what I'm doing is with a team of at least 10 researchers and artists and more people even, studying one very specific glacier on the in Southeast Alaska called the Sittline Glacier, previously or temporarily known as Malaspina. And it raises the question about the importance of monitoring glaciers, especially in Southeast Alaska. So why do we care? Hopefully that's something I will answer through these slides. That is a figure representing sea level rise for the past 25 years, and gray or purple on the top. And the blue part represents the contribution from added water into the oceans, aka most of it coming from melting glaciers. So that's why we care about glaciers melting in general, because of sea level rise. And why Alaska particularly? Because if you look at this map, this is very busy but incredible figure. Look at here and the size of the circles. This is the contribution, the melt of Alaska, of the glaciers throughout the world in the past 20 years. And Alaska has been the biggest contributor to sea level rise as a region. And more than so, it's been contributing twice as much as the second contributor in line. And what happens if we project that into the future? This is something that has been published just not even a month ago, I think. So still subject to a lot of healthy discussions happening. But what we see here is the predicted contribution to sea level rise throughout the world uh, for the next century. And Alaska is still number one by and twice as far as the second contributor. So this is why we care. Here's a map of a picture of Alaska from space, pretty cool. Doesn't have southeast because weather is always terrible there. Maybe I can move here. Yeah, I should use SAR maybe. So Fairbanks is here, and the pretty cool thing. Oh, what did I do? Okay, here we go. The glacier I study is here. We can actually see it from space. It's that kind of lump here, sit line. And a zoom view in will show you that this glacier can actually be separated into two different parts: the accumulation area, mainly fed by the Seward Glacier, and the lobe of the glacier here. One thing I forgot: why do we have a lot of glaciers in Southeast Alaska? It's because you have three main ingredients, being high topography, high elevation, very cold temperatures, and a whole lot of moisture that's being dumped by the Pacific Ocean into these mountains to get snowfalls that with time accumulate and transform into ice. And you get those big glaciers here. So in particular, the city line is one of the biggest down there. So this is a satellite image of this glacier. And I'm going to pay attention to the lobe. So try to see where the ice stops actually. Some people might think it's only that white part. Actually, if you maybe look, I mean, the contrast is not great, but you can see maybe that debris covered high ice here. But if you trace the ice, that's represented by that red line. You can see that it's touching the ocean. And we've been on the field several times, and we already detected intrusion of warm seawater in peripheral lakes around the glacier. So what does it mean? We have the Pacific Ocean that has warm water that almost never freezes, even in winter, and that water is in contact with the ice. So there's potential for the glacier to melt throughout the entire year. The other very interesting thing, and that's a figure generated by somebody in our team, Brendan Tober. I just wanted to do a small shout out to everybody working with me on that project. I'm only a small part of it, and I wouldn't do anything if it wasn't for these people around doing amazing work. And so he made this map of the bed that's laying below the glacier. And the incredible thing is that it's sitting mostly below sea level. So if you intrude warm water here at the southernmost point, there's nothing stopping the seawater, to intrude far into the lobe. So the glacier is already warming from the top. With climate change and global warming, it's gonna be worse. And on top of that, you can put water below and increase that melt even more. So eventually, all of that, if you remove the ice, that's gonna be a big lake. And just to give you an idea, this is just the lobe. This is about 700 cubic kilometers of ice. So if you put it in a cube, I'm going to translate into imperial system. It's more or less a 5 by 5 by 5 miles cube big. And this is Denali here, and this is the ice that represents, that's in the lobe. So as you can see on this picture, it's pretty big. So imagine just putting that into the ocean and seeing what's going to happen. Because the consequence of that configuration is that the glacier is susceptible to encounter to dramatically retreat over the next decades, and this is what we are working on. So how do we work on that? Oh, yeah, sorry, that's just a picture pretty cool of forest growing on this glacier, because in some places the ice is not moving that much. So, and the debris cover is thick enough that actually forests grow on top of the ice, and that's pretty unique in the world. Okay, so how do you how do you work with that? First you can go on the field, and it's always super important to know how warm it is around the glacier, how much moisture there is, I mean precipitation, and all of that stuff. And for a bit of field drama, unfortunately, Southeast is pretty unforgiving for field measurements. We attempted to measure all these parameters with weather stations, and if you take account of bears, of wind, of surge storms, and stuff like that, well, good luck to have a standing station at the end of the season. We did the same thing north of the glacier, north of the lobe in the mountains, and we had a station. We were pretty proud of that one. And a year later, we realized an avalanche probably happened and bent the pole. So we MacGyvered it and put it again for the field season. And a week later, we got a week worth of data, but the data logger was blown away by the wind, completely, shred to pieces. Another thing that we can do is put GPS stations on the ice, and those ones work pretty well. This is my advisor, Martin Truffert, just moving around, verifying everything is still here, because we got some bad surprises. So a GPS antenna is pretty cool because it gives you the ice movement both on a horizontal plane but a vertical plane, so you can see how the glacier is moving but also eventually melting. But also it gives you a good temporal resolution. So I work, for example, a lot with satellite images, or over expensive cameras from space, and take a picture only a few days at a time. So I mean, you only get a picture every day, and so. But those GPS antennas record data at a very high temporal rate. For example, 5 minutes, 1 hour, 1 day, whatever you want it to be. And that allows you to see things, mechanisms that you wouldn't see with satellite pictures. So what you do to study such a glacier, you go on the field, you put instruments out there. But sometimes the glacier is so big, like this one. Well, by the way, this is more or less the size of Rhode Island, the smallest test in the US, okay. Sometimes the glacier is so big, what you need to do is just take a bit of altitude. I mean, a whole lot of altitude. So from planes or even from satellites, and see systems as they are in their entirety. And that's something I wanted to bring to you right now, because Alaska is changing. We can see it on the images, but not the thing is that those changes that are happening right now are not only impacting us in Alaska, but have repercussions through the entire world, especially considering that Alaska is the biggest contributor to sea level rise right now. I can't end this presentation without giving a shout out to the people working with me on the field. That was an incredible field campaign, and I'm always thankful for them to be here. And also another thing is the McCarthy Summer School that was made in Alaska by glacier professors in Alaska. And as you can see on the flags, there are PhD students from all around the world that come here every 2 years to study glaciers for 2 weeks. And that's something pretty incredible that only exists in one other place in the world, in Europe. But it's not as cool because it's not Alaska. So yeah, do you have any questions?